So now we're moving on to 15b here. We're going to take a look at optimization, and this forms the biggest part of Unit 15 that we want to look at. So here are the general steps that we're going to follow if we, in each optimization question. These are taken straight from the textbook on page 305. You might want to pause the video here for a minute just to take a look at them, and then we'll move on to the first example. Okay, example number 1. We want to find two positive numbers with product 200 such that the sum of one number and twice the second number is as small as possible. Okay? The first thing I like to do in questions like this is ask myself, what are we trying to optimize here? What are we trying to make as big as possible or small as possible? And the thing that we're trying to optimize here is the sum of one number and twice the second. Okay? And we want to make it as small as possible. So let's choose some variables here. Let x and y be the numbers. Okay? And the thing that we want to optimize is, we'll call S our sum, the sum of one number, x, plus twice the second number, y, and we want to make that as small as possible. So this is what we want to optimize here. Now, are there any restrictions that are placed on these two numbers, x and y, by our question? That is one thing. So we know that x times y has got to equal 200. Okay? And is there any other restriction placed on these? Yeah. So this gives us our domain here. We know that x must be greater than 0, and we know that y must be greater than 0. Okay? So we've got the thing that we want to optimize, our sum here, and we've got this other relationship between x and y. If we're going to take the derivative of this, we don't want to have two variables in here. So we want to express this as one variable. So let's express this whole thing in terms of x. We can use this relationship over here, x times y equals 200, to say that y is equal to 200 divided by x. And then we can sub that into this expression that we want to optimize. So our sum is now x plus 2 times 200 divided by x. Okay. And this is what we're going to optimize here. Okay. Now we optimize it by taking the derivative and setting it equal to 0 and trying to find our critical numbers. So let's put this in a form where we can take the derivative a little bit easier. I'm going to write this as x plus 400 times x to the negative 1. So our derivative is going to be 1 minus 400 x to the negative 2. Okay. Now let's set this equal to 0 and solve for x. Let's see, how can we solve this thing for x? Well, let's bring this term with the 400 and the x to the negative 2 over to the other side. So we'll get 1 equals 400, and I'll rewrite that x to the negative 2 as x squared down in my denominator. I can solve this just by cross multiplying and get x squared equals 400. So what are my solutions here? 20 and negative 20. And I'll write them out separately here. Positive 20, negative 20. Now, is there one of these things we can reject right away? Yeah. Negative 20 is not in our domain. Okay? And that's why we go through this process up at the beginning of figuring out what sort of restrictions there are on our domain. So we can reject one of these solutions right away if we need to. So x is positive 20. Next up, we want to double check that this actually represents a minimum like we want, or this represents the x value that is going to give us the minimum value of the sum rather than a maximum value for the sum. So we're going to do that using the second derivative test. So we'll take our second derivative of our function here. So we've got our derivative is 1 minus 400 x to the negative 2. So our second derivative is going to be, what, positive 800, bringing down the negative 2, x to the negative 3. And we want to evaluate that at our critical number of 20. So that's going to give us 800 divided by 20 cubed. Just bringing that x to the negative 3 down into the denominator and making the exponent positive. Now, I don't really care what the answer is here. All I care about is whether it's positive or negative. And I can tell just by looking at it that this is going to be what? Positive. Right. So if this is positive, I know that I have positive, yep. I have a local minimum. And at this point, I go back to the original question and I think, yeah, okay, I was looking for a minimum, so that's good. So if I had found a local maximum, but I was looking for a local minimum, I'd go back and I'd check all my algebra again. Okay? But I found what I was looking for, so I just need to make sure that I answer the original question here. So I want to find two positive numbers. I've got one of my numbers, x. I just need the other one. So let's see, how are x and y related? Oh, y is 200 divided by x. So y is going to be 200 divided by 20 or 10. Okay? So then we just sum it all up. The two numbers are 20 and 10. Okay? And there's our answer.